A wheelchair ramp with a length of 122 inches has a horizontal distance of 120 inches. What is the ramp's vertical distance? Now it's nice because they give us the picture. That's not always the case, but in this case they give us the picture. Whoops. So we can see, right, the 120 inches, right, of the horizontal distance. And the 122 inches is the hypotenuse of the ramp. And so we're looking for that height, which is very important. There's a law, I mean, about this. It needs to be at a certain angle and distance away from the ground and the building in order to safely either come down or go up. So let's get smaller. Okay, so we have, again, a squared plus b squared equals c squared. This time we're given the two, well, we have two legs and a hypotenuse, of course. It doesn't, so that, okay, well, they used x in this case, so let's just use x. The height, right, this guy, that's x squared, plus we actually know what b is, 120 squared. And we know the hypotenuse, which is 122 squared. So again, this is just some simple arithmetic, right? You're just multiplying. So x squared plus 120 squared, right? If you punch that in your calculator, you get the following, and then 122 squared, right? And if I subtract 14,400 from both sides, I get 484. Again, if you're not sure how I'm doing this, this is in the book and they explain it step by step. And again, I want x, I want the height of this triangle, not the height squared. So this is going to be x equals the square root of 484. And again, if you punch that in your calculator, you get 22, which means 22 times 22 is 484. So the height, right, of our triangle is 22 inches. And okay, so which makes sense, right? 22 is definitely less than the hypotenuse. And well, we definitely want it to be 22 inches, right? Not 100 inches, because that would be really steep. Right, if the height was really, I mean, about 100, right, you'd have something like this. And, you know, somebody going down with a wheelchair, this is a horrible picture. Those are wheels, right? Going down or up is not safe. Okay, so that's part A. Okay, so part B is, I mean, it's really all in the book. The book does a very nice explanation. So part B, construction laws are very specific when it comes to access ramps for the disabled. Every vertical rise of 1 inch requires a horizontal run of 12 inches. Does this ramp satisfy the requirement? And notice again, some terms here, rise over run, right? That reminds us hopefully of slope. And so if we have, right, this is our rise, right, over run, right? If these are 2 points, right, that's really the slope of the line. So the construction law says every vertical rise of 1 inch, so that's the rise, requires a horizontal run of 12 inches. So for every inch in the height, right, or rise, right, we need to have at least 12 inches. So if you have a 2-inch rise, then you must have a 24-inch run, right? So for example, right, 2-inch over 24-inch. If you have 3 inches rise, then you must have, well, 12, 24, 36 inches. And, right, this is just 12 times 2, 12 times 3. And so I'll go ahead and let you read part B. Again, it does a very nice job of explaining why this works. So again, it's on page 624.